Hello there, this is the last lesson on binomials for Year 12 Maths, so we better make sure we get our head around it. And it's a new part of what we need to do for the exam, and it's using the binomials to make approximations. Now in many ways I think this is a bit daft, because in the old days, if you got asked to find 1.95 to the 6 to quite a degree of accuracy, it was quite tricky. You had to do a lot of numbers, multiplications, particularly if it was 1.95 to the 16 or something. And we can use the binomial expansions to do this relatively accurately. But I suppose really now we've got calculators, 1.95 to the 16, you can type it in and press go. It makes it a bit superfluous, really. We can work this out very accurately no matter what. And yet it's still on the exam, but nevertheless it's on the exam, so we're going to have to learn how to do it. So exercise 9c is all about doing approximations of this type, where they probably will give us the binomial expansion to use, and then ask us to use it to do a particular approximation. Bit of a reminder first of all, it says find and simplify one of these. Oh, it's one of those ones where you get lots of letters, and it's first three terms of the binomial expansion going up to 9. So I need the coefficients. And whether or not you use the Pascal's triangle or the coefficients from the NCR button, I got the three numbers to be 1, 9, 36. And obviously they carry on, but I want the first three terms. So I'm just going to do it down here. 1 plus px, it says, to the 9. So the first three terms are 1 times by 1 to the 9 and the px to the nothing, so that will disappear. It's a plus, so it will be pluses. 9 times by 1 to the 8 times by px to the 1 plus 36 times by 1 to the 7 times by, oops, not having there, px to the 2. So if I tidy that up a bit, I get 1 plus 9px plus 36p squared x squared. And it says if these first three terms are 1 plus 36 plus qx squared, alright, 1 plus 36x plus qx squared, well immediately I know now, just by linking those terms together, I know that 36 is equal to 9p, or said a different way, p is 4. And I suppose I also know that these two link up. So I know that 36p squared equals, I've done it again, equals q. Yeah, just got rid of them. So because p is 4, that's 36 times 16. 36 times 16, type it, turn it on, 36 times 16 on my calculator is 576. And that must be equal to q. So I think I've done the first two terms, hence find the coefficient of the y squared term in this expression. Let's jump to 1 plus 2, 1 plus, oh right, I suppose it's the same thing, isn't it? 1 plus 4y they've said, my p was 4, so I had 1 plus 4x all to the 9, so this then I suppose is really the same as 1 plus 2y times by 1 plus 4y to the 9, will it be 1 plus 36y, because my p is 4 and my q is 576, so I think plus 576 y squared. And it wants the expression of y squared, and we saw how we did this last time. We think to ourselves, how can we get that? Well, you get 1 times by the 576, so that'll give me 576 of them. And I think 2y times by the 36y, so plus a 72 of them, which sounds like 648 lots of y squareds. So I think 648 is the final answer. Yes, it is. So this is now doing the approximations I was talking about at the start. So find and simplify the first three terms in ascending powers, so they still want me to do this. So it's to the 5, 1, 5, 10 are my numbers. So it's 1 times by 2 to the 5 times by x to the 0, but I'm going to miss it out this time. It goes plus minus plus, we've seen that before. 5 times 2 to the 4 times by an x to the 1 plus 10 times by 2 cubed times by x squared. It's quite a straightforward one, that. That gives me 32 minus 16 5s are 80 x plus 80 x squared. So I've got my expression there for 2 minus x, and they will then want me to do 1.99. Now notice they're both to the 5s, and I suppose it's, if you look at that, 2 minus something, and I've got 1.99. If I took something away from this, you can quite easily see really I'm doing 2 minus x equals the 1.99. Both to the 5, obviously. And I reckon to do that, x must equal 0.01. Just by solving that equation. So really, to find the approximate value of this, if I substitute x equals 0.01 into the expression I got here, therefore 1.99 to the 5 is equal to 32 minus 80 times by x, but now my x I'm suggesting is 0.01, plus 80 times by, and rather than x squared, I'm going to have 0.01 squared. So this is the method we use, and ridiculously, I've now got to type into my calculator. I suppose you could do this in your head, but I've got a calculator, so I'm just going to let it do it. And I get 31.208. Now, it wants an approximate value, 31.208. I suppose it's always useful now just to check. I'm going to get rid of that dodgy line again. There. At least I've got. There we go. Just type it into my calculator, 1.99, and I'll just type it to the power 5, please. 31.2079. So actually it's quite close. The real answer then is 31.2079601 according to them. Which you can see how accurate this method is. It's surprisingly good. Next example, find and simplify the ascending powers of x, the first 3 terms of 3 plus x to the 9. So again, I want the 9th row coefficients. I want the first 3 of them. That's 1, 9 and 36. Now again, I've got the Pascal's triangle written out in front of me. So if I'm doing 3 plus x to the 9, I'm doing, that's an equals, I'm doing 1 times by 3 to the 9 plus 9 times by 3 to the 8 times by x to the plus 36 times by 3 to the 7 times by x squared. And that equals 3 to the power of 9 equals 19683 plus 9 times 3 to the 8. 59, these numbers do get big, 59,049 x plus 36 times 3 to the 7, 78,732 x squared. These are the first 3 terms. I've got the first 3 terms. Hence find an approximate value of 3.02 to the 9. So 3.02 to the 9, I've got 3 plus x to the 9. You can see 3.02 is meant to represent 3 plus x. And it doesn't take much to work out that x has to be 0.02. So therefore, we can write 3.02 to the 9 is approximately equal. And it is approximately equal because I haven't written out all the terms. This actually carried on forever. Not forever, but the first, certainly more than 3 terms. So I can just substitute x equals 0.02 into this, and I get 19683 plus 59049 times by 0.02 plus 78732 times by 0.02 squared. And therefore this is approximately equal to, so let's do this, times by, I'm going to type all these in. Okay, I've got them in, I've got 20,895, what does it say to do? To 4 decimal places, which is good because that's what it says on my calculator, 4728. use the exact answer for it. Okay, it wants me to do the exact answer, so I'll type this in. It's exactly equal to 3.02 to the power of 9 equals 20895. It seems very close so far. 0.96762. So it's not exactly the same. And it wants me to calculate the percentage error. So to get the percentage error, first thing you do is you find the error. So if I take one away from the other, I get a difference of 0.4948. There's lots of decimal places. I shall write them all down. But then, of course, to get the percentage error, you divide by the actual number. So it equals this divided by this, the actual number. So I'm just going to now divide by that 20895.96762. Oh, it's a rather horrible decimal. I get 2368. And of course, you times it by 100 really to get the percentage. So if I times it by 100, I get 0.00. It says to one significant figure, 2%. That's really small. And that's what the answer actually is. That's handy. Harder questions. Now, these are potentially harder because you have to work a bit harder to work out what the x has got to be. So my first example here is 1 plus a quarter x to the 4. So I suppose the first thing is just to remind ourselves that it's because it's to the 4, I want the first 3 terms of that fourth row. I think my coefficients are 1, 4, 6, 4, 1 it goes. So 1, 4, 6 is what I need. And I want the first 3 terms. So I'm going to 1 plus a quarter x to the power of 4. Is about equal to, and it's about equal to, but I'm only writing the first 3 terms. So, what is it? So it's 1 times by the 1 to the 4 times by, well, the quarter x to the 0, not going to bother with that, plus, because it's a plus in the middle, will be a plus, it's 4 times by 1 cubed times by a quarter x to the 1, plus 6 times by 1 squared times by a quarter x squared. So what's this equal? It equals 1 plus 4 over 4 is 1, so that's x, plus, well, be a bit careful, it's a quarter squared, so both numbers have to be squared. That's like a 16th, 6/16, so it's 3/8. 3/8 of x squared. So that's that done. I've done the expansion, and it now says find the approximate value of 1.025 to the 4. So obviously it was to the 4 originally, so really what we're saying is 1 plus a quarter x has got to be equivalent to that 1.024. 0.25, sorry. So take the 1 onto the other side, that gives me a quarter x equals 0.025. And therefore x equals, what do I get? 0.025 divided by, divided by a quarter. 0.025 divided by a quarter, and I get a tenth. I get x equal to be 0.1, and that I don't think is obvious. You could easily go wrong there. So if that is 0.1 and I've done everything correctly, I can now type that into my expression, which I want, is 1.025 to the 4, and this therefore I can use this expression here with my x equals 0.1. So it's 1 plus by 0.1 plus 3/8 of 0.1 squared. What's that? Type it in, 1.1 plus 3/8 times 0.1 squared. And I get 1.1. How many decimal places do I want? 3 decimal places. 1.104. See if I got it right. 1.104. Yeah, so it's done. So I've run out of time. There's got at least one example to go, an exam question to go, and then we'll be ready to start the exercise. But at least that saves us a couple of questions to go through in class. So thank you very much. Good luck.